Now, say we have any two arbitrary vectors, a and b. We can find the angle between them, just as we have done in the past. That is, theta would be equal to cosine inverse of a dot b per the magnitude of a times the magnitude of b. Now, we have to take the dot product to populate the numerator of our cosine inverse trigonometric function, and we also have to multiply the magnitudes of our two vectors to populate the denominator of our cosine inverse trigonometric function. Let us look at an example of how we do this. Say we have vectors a and b, and we want to determine the angle theta between them. First, we must take the dot product of a and b. A is going to be defined as 2.0, 5.0, 5.0. B is defined as 5.0, 0.0, 3.0. When we take the dot product, we have 2.0 times 5.0 plus 5.0 times 0.0 plus 5.0 times 3.0. And we have a value of 25 once we consider significant digits. Next, we have to find the magnitude of vectors a and b. The magnitude of a is equal to the square root of 2.0 squared plus 5.0 squared plus 5.0 squared, which is equal to 7.3 after taking into account significant digits. The magnitude of b is equal to the square root of 5.0 squared plus 0.0 squared plus 3.0 squared, which is equal to 5.8 after taking into account significant digits. Therefore, we can calculate the angle between them as the cosine inverse of 25 per 7.3 times 5.8, which would be 53.81 degrees, but since the quantity within our trigonometric expression is limited to two significant digits, we are going to express this angle in the tenths place, and we'd report this to 50 degrees.